Okay, then let's go with the first practical exercise. So for the first practical exercise, also download the data file. I already uploaded it over there in the Google Drive, and the link is also down below. You can go there and like download the data file. For this exercise, what we are planning to do is uh, 100-year flood event predicted for Kelani River is like inundation zone and estimated 500 meter from the river bank and low level lying areas. So for this one, what we need the Candy or like stream network of Sri Lanka. From there, we have to extract the Kelani Ganga or Kelani River, and then we have to create a buffer from 500 meters, and then we have to identify the total number of buildings. That means we need to have a building data layer as well, and from there we have to estimate how many damage is going to be happen if it is going to what we call is going to have a flood like this, and then we have to count how many buildings are going to affect, and then we have to go with like flood zone. There is like high risk or moderate risk or overlaid with 10-meter digital elevation model. So without further ado, let's jump in. Let me open ArcMap from 10.2, ArcMap 10.2, 10.8. Okay, the map has been loaded. Let me close and click new. You know the drill, same thing. Click on folder connection. Local disk D, practical 1, then add the folder, back 0201, select, OK, file, yes, 1, 1, save. Now load the data. Go to the catalog, load the building layer, again drop it. So these are all the buildings in Sri Lanka, and then drag and drop the digital elevation model, and then drag and drop the stream network shapefile. So the first things first, what we need to do, we need to extract the Kelani River from this stream network. So this is the guide for the practical one that you have to follow. So first thing, you need to go either 44N or use on the color coordinate system. Then you have to enable the spatial analyzed. Same thing, right click over here and check whether this partial analyze tool is enabled or not. If not enable that thing, and then first thing we need to extract the Kelani River. So how we can extract the Kelani River? Right click on the stream network, open the attribute table, and then select by attribute, click over there, and then click name equal get unique values. You scroll down till you get Kelani, or you can type Kelani Kelani Ganga and then click apply. So after that you will see Kelani Ganga was highlighted over there. Then you can click close. Now how we can clip this one? Go to the search for the tool, clip, analysis, input, stream network, clip feature, stream network, output, Kelani River only, and click. Now it will start processing clipping only the Kelani River from this dataset. Now if I right click in this layer and open the attribute table, you can see only the Kelani Ganga has been highlighted. So now let me switch off the building layer for a while because it is taking some time to load. I will remove the stream network layer from there because I had the thing that I want, the Kelani River stream network. So now what I have to do is I need to create a buffer zone. So how to create the buffer zone? We can search for the tool buffer, analysis, and then click on Kelani River only. So you can give this one a name, Kelani River over flat zone 500-meter buffer. Here you can select meters, and then linear unit you can select 500, and then side full, type round, method planner, dissolve, whole, and click OK. Now you can see the buffer has been created for the Kelani River. So we will estimate if a flood is going to occur, these areas are in a huge risk. Now what we need to do, we need to calculate how many buildings will be affected if this kind of flood is going to happen. It's like a rough estimation. So how we can do that estimation? So now we need to count the vulnerable building by using the spatial join. How we can do this one? Just search for spatial join tool, the analysis, and then targeted features, select buildings, and then targeted feature, not the buildings, you have to select Kelani River flood zone, and then join features, you have to put the buildings layer, and then you can give this one name, flood zone building count, give the flood zone building count, and then join one to one, click all the targeted features optional, right click, you can click on add field, and then here I will type count, and then merge rule by count, click OK. So if I click over there, I have a new field and type as count. So now click match option intersect, and then rest of the things same, and click OK. After that, if you right click over there and open the attribute table, here you will see a field name joint counts. So that means how many buildings are covering within or fall within this specific region. So if I turn on the building layer, so you can see these small points are buildings. So if I turn on that layer on, you will see this much of buildings are going to affect if the Kelani River is going to get flood all the way from top to bottom, but not all the buildings are going to affect. This is just a rough calculation or rough estimation. So now we have the number of buildings. How many buildings are there? 33,806 buildings are there. So if we need to calculate, okay, we are going to issue 50,000 or somewhere around that for one building. So now you have the count. So with that thing you can provide a rough estimation, because from here from the summary table estimated property value you can say uh, output the vulnerable buildings, and then you can say we have roughly 33,806 buildings are there. So multiply it by the value that we are going to provide, then you will have a rough estimation of the properties at the risk. So that part is done. Then the next one is how we can incorporate the DEM or the digital elevation model with this one. For that thing we need to use the digital elevation model. For that one we will use extract by mask tool. So if you search for extract by mask tool under this partial analyze, for the input raster you can give the DEM file. Then for the input raster feature mask you can give the Kelani River flood zone 500 meters, and then you can give this one a name, flood zone DEM. So this is the flood zone DEM, and then click OK. Now what will happen? It will start clipping the DEM file along this 500-meter buffer zone. Right now you can see the DEM has been clipped alongside this 500-meter buffer zone. So now we can do the reclassification part. So we can consider, okay, if the elevation is between this range, it is like low risk, and if it is like higher elevation, it's like low risk, and if it is low elevation, it is at high risk or moderate risk. So now we need to do the reclassification. We can search for the tool reclassification. Reclassification and partial analysis. Load the flood zone DEM and then go to classify. Then here you can specify the value. I will give like 3 values. I will give 3. So here I will type one tile. So it's like 1967 and then 122. So this one will be from minus 11 to 19. We can consider as high potential regions, and then minus 19 to 69 we can consider as like lower regions, and then 67 to 1128 we can consider as higher risk zone. So after that we can give it a name, flood risk zones dot diff, or I will give flood risk zones, and then click OK. After that you will have a file like this. So if I turn off the building layer and then see, this is the one. So I can go to the properties, and then I can go to the symbology and then give these values. So these are like low elevation, and then these are higher elevation, so now you can give the colors. So this one should be like red, this one should be like yellow color, and then this one should be like totally okay, green color. So now you see the buildings at risk. So here this region is totally fine, and then at the what, like it's like the mountain region, and then when it comes to down, we don't have that many region, but when it is coming past this region, how it is going to affect. So for this one, let me add the other file from another one, like our gnd file. Yeah, we put the gnd file over there, and this one at the bottom. From there you can see how it is going to be affected. Most of the granular divisions in Kalambu district is at risk. So now you can do the visualization as well, and even do the visualization of this one in a map. If you go to the layout, you can do the simple visualization. So I will zoom it into the flood risk zone, and now you can do whatever thing, like at the north arrow, put the grid, and then get the estimation. So all the other rest of the things are here. You can follow along with this one, and then create the output. You can like create the output, like the field calculator, and get how many buildings are at risk. So flood risk zone is there. You can like input the building feature, group the buildings, and then vulnerable buildings you can get, and then after that you can do the field calculator at the field the estimation value, and then you can do the field calculation, and then count and give something like this. And even you can give a make a thematic map like this based on the criterias.